Okay, so chances are this is the type of thing you're going to get with x's, alright, because that's, otherwise you can just throw it into your calculator. So there's a few ways you can do this sum, okay? You can either put that half into the top and put the half into the bottom, or you can simplify in the bracket first and then raise it to the power of a half, okay? It's probably easiest to do the bracket part first, okay? Now everything's being multiplied here, there's no pluses or minuses, so that makes things much easier. So this is x squared over x to the power of minus 4. What do you do when you're dividing? Minus them, don't you? So 2 minus minus 4. And the same with the y. I've minus 3 and I'm minusing the bottom.
Are you just bringing them up to the top?
Exactly, yeah. Okay, so that's 2 minus by minus is plus, so that's x to the power of 6, and this is y to the power of minus 8 to the power of a half. I've two things in the bracket to the power of a half, so what do I do with the power of a half? It goes into both, doesn't it? So it's x to the power of 6 to the power of a half, and y to the power of minus 8 to the power of a half. And here we have power bracket power. What do we do? Multiply. Okay, power bracket power multiply. So 6 by a half is 3, and minus 8 by a half is minus 4. Okay, and normally the way you write that is you'd bring the indice to wherever it would be a plus. So that means I need to bring it underneath to make it a plus. Okay, but both are correct.
Are all those rules in the logbook?
All those rules are in the logbook, yeah.
I'll leave those here.
Yeah. Yeah. Are there any issues with that? This is where you're going, page 21, if you want to write it into your example copy. Page 21. Here you have them all. Okay? So we just used a combination of these to solve that problem there, or to simplify that problem. Okay? We used this one because we had the power, or we could have used that one. We had this one. We had the dividing. Okay? So they're all there for you. So you just need to go to them. Right, let's do part 2. Can I get rid of the board? So we're simplifying this. If they're all different letters, then your bases aren't the same, and then it's very hard to do anything with them. So they want them, the bases, to be the same so that you can actually do a sum. Yeah. Okay, so what we have here is all the bases the same. That's A. In order to deal with these nicely, you should probably get them a to the power of. Okay? So, how do we change square root? What's it to the power of? A half. Excellent. So really that's a 2 out there, isn't it? Okay. Now, we have a 3 in here. Bottom number, outside, top number, inside. So the top of the fraction is the one that's inside, and the bottom of the fraction is the one that's outside. So that's actually a to the power of 3 over 2. Because it's square root. Normally square root is just like that, but it's the exact same as that. It's the same thing. It's just because it's square root, we just have gotten rid of that 2 just for ease. Now we just say this. Okay, but it is, a 2 is out there. That's what square root means. Okay? You're trying to find what by itself twice. Okay? Now here, this is the fourth root of a. So that would be a to the power of? A quarter. Excellent. Multiplied by, this is the cubed root of a squared. A to the power of bottom number outside, top number inside, 2 over 3. Okay? Let's keep going, tidying up a little bit. What do you do when you're multiplying and the bases are the same? Add your powers, exactly. Are you okay?
Yeah, but what do you mean by bottom number and top number?
So, of your power, you've the top and you've the bottom.
Also come off the top.
So, no, as in, like here, if I want to change this to a to the power of something, I'm calling it the top and the bottom. Top and the bottom. Okay? So its bottom number comes from the outside, top number comes from the inside. It's just a way to remember it. Okay? Now, you told me when I'm multiplying with the same bases, what do I do with my powers? Add them. Okay? So I've just thrown that into my calculator there and I get 11 over 12.
How do you get 11?
I just threw it into my calculator, is what I said. Literally a quarter plus 2/3. You'd need to get a common denominator.
Oh, and you're multiplying.
Yeah. So you'd get a common denominator, they'd both be 12. Okay, so 4 goes into 12 3 times, so 3 goes on top, 3 goes into 12 4 times, 4 2s is 8, 8 plus 3 is 11 over 12. Okay, but your calculator does it for you. Now what do I do when I am dividing? Minus them. 3 over 2 minus 11 over 12. Okay, and my answer is 7 over 12. Okay, so when you're dealing with square roots, sometimes it is easier to change them to powers of a half or cubed roots, powers of a third, because then you can actually work with the bases being the same. Okay. Can I get rid of this? Is this example 2? Great. Be very careful with that dot. That's not a decimal point. Okay? It's a multiply. Yeah. Excellent. So show that this thing equals 25 over 26. Now, that's given to you in the question. It doesn't mean you have to use it. You can just use multiply or brackets. Okay. If I want to be able to work with these, what has to happen? They all have to have the same base. Okay? So they all need to be 5s to the powers of something. Have a look at this. This is 5 to the power of n plus 1. What's happening in the powers? You're adding them, aren't you? So what must you have done before this in order for you to be adding your powers? Multiply. Yeah. You're multiplying with the same bases. Then you add your powers. So working backwards, the powers are being added. So I can actually change that 5n plus 1 to be 5 by n by 5 to the power of 1. 5 to the power of n by 5 to the power of 1. Because if I was to actually do this, it would be, I'm multiplying, my bases are the same, 5 to the power of, add the powers, n plus 1. Okay? Minus 4 times 5 to the power of n. I'm just getting rid of that little multiply and making it a bracket because I like that better. Down here, it's the same thing. 5 to the power of n minus 2. Okay, perfect. You can do it that way. 5 to the power of n, 5 to the power of minus 2. Normally what's happening when we're taking? It was being divided, wasn't it? So it would be 5, it's totally up to you which way you do this. 5 to the power of n over 5 to the power of 2. Okay, because if I'm minusing my powers, I was dividing. Plus 5 to the power of n, can't do anything there.
You know the minus 4?
Yeah.
Is that not a decimal?
No, that's multiply. Yeah. Okay. So normally a decimal is like that. Multiply then is like that. I don't like using it because it gets confusing. Exactly, yeah. Now, up here, let's just keep tidying. This is 5 by 5n minus 4 by 5n. 5 5n's, take 4 5n's. What have you left? Yeah, good. 5 by 5 to the power of n minus 4 by 5 to the power of n. That would be 1 by 5 to the power of n, or just 5 to the power of n. Okay, let's leave it like that for a second. Now, down here, what can I do? Like, I'm trying to simplify it to be this. I have something like this on the bottom. What would I normally do with a fraction like this on the bottom? Get a common denominator. Yeah. Get a common denominator. What's my common denominator going to be? And like, you don't have to use indices here. What's 5 squared? 25. You can use 25. That's fine. So 25 by what gave me 25? Just 1. So 1 goes on top. 1 by what gives me 25? 25. So 25 goes on top. I'm getting a common denominator. So what did I do to this to make it this? I just multiplied it by 1. What did I do to this to make it this? I multiplied it by 25. If I multiply that by 25, I have to multiply that by 25. Okay? So on top, we've 5 by 5 to the power of n minus 4 by 5 to the power of n. So what's that? 5 to the power of n. And on the bottom, I have 5 to the power of n plus 25 times 5 to the power of n. How many 5 to the power of n's have I? 26 by 5 to the power of n all over 25. Okay? How do I divide with fractions? Turn it upside down and multiply. So it's 5 to the power of n divided by this thing, which is 5 to the power of n multiplied by, turn it upside down, isn't it? Okay, so 5 to the power of n, all I've done is put in the divided sign, divided by this fraction. So I know I turn it upside down and multiply. What's going to happen here? It's fractions, so I'm doing top by top. 25 by 5 to the power of n over 26 by 5 to the power of n. Cancel the 5 to the power of n's, exactly. My answer is 25 over 26, which is what they wanted me to show.